I won't say it should be obvious that we would want to know how fast a function is changing. You want to know how much a function is changing by at any given point, but hopefully it is understandable that we'd be interested in being able to know that for, say, making a prediction about how the function might change at a given value, because we don't know for sure that's always going to be doing exactly the same thing. And that's in particular one of the main focuses of calculus. For those of you who are going there this week, is a lot of calculus adjacent material, so you're going to be hearing about it a lot. But for us, when we're dealing with slope, as it's called, the description of rate of change, as we'll see later, the easiest way to look at it is in the context of functions with constant slope. That is, well, linear functions. So if we're trying to find the slope of a line between 2 points x1, y1, and x2, y2, that's just rise over run. That's the amount it goes up over the amount it goes from left to right. That is y2 minus y1 over x2 minus x1. So if we wanted to find something like the slope between the points 1, negative 2, oh boy, my 2, to the points 3, 1, we just look at how much the values are changing along that path, where we usually denote this value with the letter m. That notation comes, well, at least in English, from the Irish mathematician Matthew O'Brien in 1844. The general idea of slope, as I said, it's a pretty old thing, but it's specifically defined for our context yet again by that Frenchman that we're not going to talk about too much because he's gotten enough of our time in this class already. Anyway, here we're looking at, as I said, rise over run. So rise is 1 minus a negative 2 over run, which would be 3. That's not a 3. 3 minus 1. And technically speaking, if you flipped both directions here, you'd get something very similar, but you'd sort of get it backwards. So we always do the second minus the first, where in this case, that would end up being 1 minus a minus 2 is 3 over 2. So the slope there is 3/2. And as I said, we can use slope specifically really nicely in the context of lines to talk about a couple of ways that we can express lines in terms of this value. The first one we're going to look at is generally the easiest to get to, and it's what's called point-slope form.